So let's talk about the derivative of a function. So if f of x is a real valued function, then the derivative of f of x, denoted as f prime x, at a specific point a is given by the formula f prime a is equal to the limit as h tends to 0 of f of a plus h minus f of a divided by h, where h is a very small real number. Now let's also try to understand what this formula means geometrically. Right? And so for that, let's take a function So here is our function y is equal to x square. Let's plot this. And let's take only a part of it which is of interest to us. So here is our function. Now let's denote point A as this point and a plus h as this point. Therefore, this is f of a and this is f of a plus h. Now, one way to get an approximate value of this a plus h, f of a plus h, is to draw a tangent at this point. So let's do that. So here is our tangent to the function at this point. Now let's also complete this triangle over here. Now you see this is a right angle triangle, and if I denote this angle as theta, right, now this formula over here is going to give me, see, this is the numerator, this is the denominator. This formula is going to give me, in terms of this angle theta, the opposite side divided by the adjacent side. And I can approximate this opposite side as f of a plus h minus f of a. See, it's only an approximation because the true value of f a plus h is this, whereas the approximated value is this point. But as h is going to get smaller and smaller, this gap is also going to get smaller and smaller, right? So what is this formula for the derivative giving me? It is giving me the opposite side by the adjacent side, or in other words, it is giving me f of a plus h minus f of a divided by h, which is, from trigonometry we know, the tangent of the angle theta, and that we know is also equal to the slope of this tangent at the point A. So what is our geometric interpretation of a derivative? It is the slope at a specific point.